I started off as an anthropologist at the University of Pittsburgh. Studied both archaeology and it's called physical anthropology, the study of the biological aspects of humans. I hadn't really heard a whole lot about the field of forensic anthropology, and this was in the 70s, and in reality the field of forensic anthropology had not been around very long. We always have photographs, we always have a written account of what the scene looks like and who's involved with it and the whole process. And then there's what we call a cartographic component, which is a mapping. This is what archaeologists do, is make maps of the evidence, for example, and the distribution of it. And so if we have a buried body, we'll have a nice hand-drawn map of what that thing looks like, but it's basically in 2 dimensions. The goal isn't just to find the gun and the body, it is to reconstruct what happened in the past. The last 15 years, we've added the technology of electronic total stations, which will give us a 3-dimensional rendering of the scene. And then if you take enough points, then you can document not only the buried body, but the surrounding area, the roads, and et cetera, as you go out. Then the next level was adding the survey grade GPS. The GPS tells you exactly where you are, and it's a term called georeferencing. And so once you georeference, then you can go into Geographical Information System, GIS. If you go into GIS, somebody has characterized what the soils are in the area. They've described and noted what the trees are, the characteristic trees, and where the nearest river is, and it goes on and on. Then the next level would be the 3D scanning of the scene, so that you can, rotate and look at it from different angles, different perspectives. And the focus of my career is how we collect the contextual information in the scene. And then when we take it back to the lab, we can interpret how the bones are modified and answer all those other questions. And so it's important to document that. And in the past, certainly it was 2-dimensional pictures. If you can scan it and produce that image, then that's even better. I purchased a Spider about 6-8 months ago. And so whereas in the past, what we would do with our markers of the age of the individual, we can look at a number of different areas. So what we've done in the past is take like dental stone and cast it. It's a long, involved, and expensive process, and oftentimes the results aren't great. So we've replaced that part of it with a 10-minute scan of the bone, and so we have a virtual model that we could then 3D print. And we don't have the actual specimen, but we have as close as we can get to the actual specimen that they can hold in a 3D printed scanned image. I was thinking, in my line of work, it would be a highly detailed rendering of the bones, capturing these age markers. But the other one was what I do in the field. For example, I've seen people with scanners of it, and that would be the best solution. And so I was looking for something that would do both of those. I think the favorite thing is that it's very, very user-friendly. I basically bought it and then turned it over to the students. And so I have a couple students that I said, try to figure it out, and in a weekend they're experts in it. The images that it generates is just spectacular. That's one of the key things. For example, we're trying to get into the VR world, and if you're going to do that, you can't have fuzzy images or low resolution. It's not going to work. And so we need the best available, and that's what the Spider provides.